Welcome. So it is my great pleasure to welcome you to the second plenary talk at YLMP, and a great honor to introduce Professor Marc Brysbaert. Professor Brysbaert is a professor at the Department of Experimental Psychology at Ghent University in Belgium. His research interests include, among others, cognitive neuroscience, neuropsychology, memory, and foreign language learning. Professor Brysbaert is an ad hoc reviewer for manuscripts sent to nearly all journals in experimental psychology. He's also a reviewer of research projects sent to a number of science centers, including, among others, ECRC, ERC, or National Science Foundation in the US. Between 2013 and 2017, he served as an editor of the Quarterly Journal of Experimental Psychology. He's currently the member of the governing board of the Psycholinguistics Society. This year, Professor Brysbaert was awarded a Sarton Medal for his contribution to the history of science. Today, Professor Marc Brysbaert will deliver a talk on linguistics, psycholinguistics, and big data, the way to the future. The floor is yours.
Thank you for the nice introduction and also for the invitation. It's a pleasure to be here. I'm looking at the program and also having attended a few lectures this morning, I'm afraid I may have chosen the wrong topic, because I have a very beautiful talk about second language processing, but unfortunately I'm not going to give it here, so that will be for another time. We will be looking at another topic, namely the kind of link between linguistics and psycholinguistics via big data. Sometimes it's nice to go a little bit outside your comfort zone, to hear something you're maybe not so familiar with, so that you learn something new, let's hope. Okay, in the good old days, we as psychologists, we were running experiments on language processing. For instance, we wanted to understand how our words read, how our visual words recognized. And what we would do is look at the variables that influence the speed with which we can recognize words. And one of the big variables is word frequency. Words you often encounter, you often read, you often hear, these are the words that you can process most rapidly. Yeah? It's kind of a practice effect. And this, everybody accepted it, but then there were two authors who said, yeah, maybe it is not word frequency, but the order in which we learn the words that is important. So the first learned words would be the ones that we recognize most rapidly, and this would be the effect of age of acquisition. Now these two people were Morrison and Ellis, more than 20 years ago already, who said, if you look very carefully, the effect of age of acquisition is stronger than the frequency effect. So they had two, doesn't work very well. They had two experiments. On the top you see the naming, and what they had was one list that, a pair of lists that differed on age of acquisition, and that were matched on frequency and a few other variables. And you see in naming that the early acquired words, the words learned first, were named after 615 milliseconds, and the ones that were learned late were named 30 milliseconds longer. And then they had two lists in which the frequency was manipulated, and there they didn't see a difference, making them conclude that age of acquisition was more important than word frequency. They also did a lexical decision task, and in this task they found both effects, but they said naming is more important than lexical decision. To some extent, it's an interesting thing to look at how people do this type of research. Yeah? For instance, if you look at it, they had 21 participants, all psychology undergraduates, as we all do. They also had stimuli. There were 24 words per list, so that's 4 times 24 words, 96 words. Age of acquisition, they had gotten this from a study which asked students to rate at which age the words were acquired. The frequency measures, they were based on a frequency list by Kuchera and Francis that was collected in 1970s. 67, and that included 1 million English words. Yeah? So that's what they are using to make these theoretical claims. Shortly afterwards, there were some people who said, yeah, but this age of acquisition effect, it is true, but we also find a frequency effect. And in addition, if you look very carefully, the frequency effect interacts with the age of acquisition effect such that the frequency effect is larger for late acquired words than for early acquired words, or that the age of acquisition effect is bigger for low frequency words than for high frequency words. There were other people jumping on the wagon, they had some data, and they said, yeah, we also find an age of acquisition effect and a frequency effect in the Dutch language. Now, this, as I said, was something like 25 years ago. Yeah? So this is the type of things we did, which is now called small factorial designs. And if you look at some features, they usually include something like 20 to 24 participants. That's the typical sample for an experiment. They also have something like 20 stimuli per condition. Yeah, that's a typical stimulus size. We manipulate 1 or 2 variables and we look at the effects. And we try to match the lists on all other variables we think are important. Yeah. And which variables are important? Yeah, we base ourselves on our intuition. Most of the time, other variables must be included because the reviewers who read this have a few other variables they can think of that should have been matched, and so they ask extra data for that and a few other things. But there are also some problems with this approach. Namely, and Balota and colleagues have interviewed or summarized a few of them, can we really match these stimulus lists? On how many variables do we have to match them? And why are these variables important? And how important is it that we match them on these variables? We don't know. Yeah? So we're just thinking that they are important. Another thing is that if, for instance, you present half low frequency words and half high frequency words in a single experiment, participants will rapidly notice that half of the words are very strange words they haven't seen that often, and half are very easy words. So what kind of effect will this have? If you, in addition, you also get words that you saw a lot when you were a child, these early acquired words, and then a lot that you recently acquired, you start maybe not seeing through it consciously, but we can show that it has an effect on your responses, for instance, in a lexical decision task. Something else is that both age of acquisition goes from year 2 to current age, and frequency goes from 1 in maybe a billion words to several millions per billion words. So these are continuous variables, and we cut them in 2 lists. We dichotomize them, low frequency versus high frequency. Yeah? And what do we define as low frequency and what do we define as high frequency? There is also evidence that when we are selecting these words, as an experimenter, we know that some words will be more difficult than other words. Certainly for the low frequency words, you have a feeling that some words are easier than other words. I'll return to that. So if you want to show a strong frequency effect, you can select the words, the low frequency words that are difficult. If you don't believe in a frequency effect, you can select the low frequency words that feel easy. We don't know why they feel easy, but we have this intuition, oh, this looks like an easy word. And something else, we have stimuli taken from extremes. Yeah? Early acquired, late acquired, low frequency, high frequency. Maybe these extremes are strange words. Yeah? Certainly if you're looking at something like early acquired, low frequency words. Now, if you don't don't pay attention to this, you get all types of words that has to do with toilet training and this type of thing. So the type of words you are using to babies that now you are not using anymore, and that certainly are not frequent in the type of corpora we are studying. So to what extent are these words really representative to hang a complete theory on? Yeah. And some more problems. Also, as we now know, you know, the replication crisis, a few of these things don't replicate. Yeah? And we now know that with 20 participants and 20 stimuli, you have a strongly underpowered study. I've done some research on this, and recently I've stuck out my neck and said, if you want to do proper research in language, you need 40 participants and 40 stimuli. If this is the type of number you achieve, you will have replicable results. With everything less, it will be difficult to find the usual effects. How good are the measures we are using? Yeah? So I said, Morrison and Ellis, they took the age of acquisition estimates from a list that was available, that had been collected in Aberdeen. When did you acquire these words? Is this applicable to their participants? Yes or no? They used the list of word frequencies collected 30 years earlier. How good is this? They didn't ask, they just used these measures. So, how good are they? And another question, what is high frequency and what is low frequency? If you read the complete text of Morrison and Ellis I showed you, they define low frequency as less than 10 per million words. Yeah? And high frequency as words with a frequency more than 100 per million. Yeah? So there is a big difference between low and high, but is this the best difference? Yeah? I once had a discussion among people, what do you define as a low frequency word? And then there was, oh yeah, less than 10 or 5 per million. That was kind of the consensus in the room. Okay, remember that when we will be looking at the frequency curve. So how does this frequency function look like? Yeah? To some extent, imagine physicists, after 50 years of research, still saying that water of a temperature of 5 degrees feels colder than water of a temperature of 20 degrees. That's basically what we are doing. Yeah? We are not looking at the curve itself, we are just looking at low and at high. And we are not even agreeing or knowing what is low and what is high. We are just saying low is lower than high. Yeah? That's basically what we are doing after 50 years of research. Yeah? That's basically where I get the conclusion. So, and then in 2007 there was an interesting study published by Valotto which really struck a note with me, because I wanted to do something similar already for ages, but at least he dared to do it. Namely, he said, the alternative is mega studies, big data. Yeah? And he presented the English Lexicon project, in which they had naming times not for 90 words, not for 100 words, not for 200 words, but for 40,000 English words. Virtually the complete lexicon, yeah? Or half of it, let's say. In addition, they also had lexical decision times for these words, so that suddenly you had a lot of data to work with. Yeah? Rather than these 24 or 24, you suddenly had 40,000 words going from low frequency to high frequency. So this also got rid of the biases you may have in selecting your stimulus materials. Everybody got a random selection of these words, of all these words. So no more a priori selection. It allows a number of things. Yeah? Rather than work with ANOVAs, we now can work with a regression analysis, which actually are a better way of analyzing data. One of the problems with words is that their features are inherent. So you cannot manipulate the frequency, it's very difficult to do so. You cannot manipulate the frequency of a word, you cannot manipulate the age at which it is acquired, or it's very difficult to do so. So basically you are trying to measure existing features, and regression analysis is much better suited for this type of data. In addition, you can use continuous variables to look at the effects, etc., etc. We can also look at the determination of the frequency curve. This has been, let's say, the quest of my last 20 years of my life. How does the frequency curve look like across the entire range? And then we also can validate our word norms we have. How good are these frequency measures? Can we improve on these frequency measures? How do we do this? We look at how much percentage of the variance they explain in the naming times and in the lexical decision times. A good frequency measure, we would predicts more, explains more of the variance in naming times and lexical decision times than a bad frequency measure. So we can start to look at the best frequency measure. And also we can run virtual experiments. If we have data for 40,000 words, we can take the stimuli that Morrison and Ellis used, look at what the reaction times were to these stimuli for the group, and see whether we can replicate their findings. And that's basic. This is where you can find it, so the English Lexicon project. Everybody can download it from the web, except that last 2 days it has been down. They are working on it, I've been told by Dave Balota. They will upgrade it a little bit, and so it's down for this very moment. So what we can do, so we have the English Lexicon project, we can repeat Morrison and Ellis. So they found that early acquired words in lexical decision tasks were fast, responded to more rapidly than the late acquired words. There was a difference of 66 milliseconds. We can look in the English Lexicon project for the same words, what was the reaction time to these words, and again we see a nice age of acquisition effect, 52 milliseconds. And if you look at the data of Gerhard and Berry, we can replicate the age of acquisition effect, but strangely enough we cannot replicate the frequency effect. So again suggesting that age of acquisition may be more important than frequency. But the nice thing about these mega studies, lots of data, big data studies, is that you can do regression analysis across all the words. It's no longer 24, but it is 40,000. And we can look at the correlation between these measures and, for instance, the lexical decision data. And then we see that frequency, indeed, has the highest correlation. But that this correlation is not so much higher than the one with age of acquisition. They are kind of quite close if you look at it. We also see that the length of the word, number of letters, number of syllables, that this also has quite a strong effect, and that the similarity to other words, which is the OLD20, it's a measure of how far is this word from other words, this also has an effect. So now you're starting to get a bit of an idea of what are the important variables in visual word recognition. Of course, these variables are intercorrelated, because words that are acquired early tend to be high frequency words, words that are acquired late tend to be low frequency words, so there are intercorrelations, and we would like to do regression analysis. And for instance, this is a regression analysis we did. If we enter frequency and age of acquisition in these ELP data, we explain something like 55% of the variance. Some 80–85% of the variance is systematic in the English Lexicon project. So that means that we are explaining quite a big chunk. It also means that we are still missing some variance. So which are the variables we are missing? We can also look at frequency together with all the other variables that are important, the number of letters, the number of syllables, and the similarity to other words, and then we see that we are explaining something like 61%. If we then still add age of acquisition, just to have an idea of what's the pure contribution of age of acquisition, we still find that it explains 4% of variance, which with 40,000 words is highly significant. So it is beyond doubt that both frequency, age of acquisition, length, and the similarity to other words, that these are the big variables. Yeah? This is what you must control if you want to run a study. But this is the nice thing. Yeah? Now we can look at it. We can look on data, we can see new variables that are introduced, how much extra do they explain, and most of the time it's only 0.1/10 of a percentage that they explain. They can be theoretically important, but in practical terms they don't make much of a difference. But at the same time, we were kind of, because of this work, we were kind of confronted with the question, are these data, are these norms we are using, I've now talked about age of acquisition, I've now talked about frequency, are these really the good measures? Yeah? And for instance, Morrison and Ellis, as I said, they used Coursera and Francis. That's a very small, based on a very small corpus of 1 million words. It's also now already 50 years ago since it has been published. To what extent is this frequency measure still a good one? And what we did was collect new frequency measures and correlate them with the data of the English Lexicon project. And what we saw there, if we for instance look at reaction time of all the words, we saw that Coursera and Francis, together with length and a few, with length, explained something like 57–58% of the variance. However, if we looked at other frequency measures, we saw that they were doing much better. In addition, the difference was particularly big for the short words, yeah? The monosyllabic words. Now, these are the words that are used most often in research. Yeah? People usually work with short, easy words that can be controlled on a number of variables. There you see a difference between 39% of the variance explained and 48% explained by the best possible frequency measure. The less variance is explained by frequency, the more variance there is for other variables to have an effect. Yeah? And also, if you put age of acquisition against frequency, if you put age of acquisition against a suboptimal measure of frequency, yeah, then you don't have to be very surprised that you don't find a frequency effect, because you're using a bad measure of frequency. And we looked even further at the monosyllabic words, and if we looked at how much was explained by Coursera and Francis for this particular type of words was 32%. If we added age of acquisition and familiarity, we went to 51%. So there was a huge effect possible for age of acquisition here. But if we looked at new and better frequency measures, we saw that they explained more of the variance, and so that there was less left for the other variables. What we also found, and this was against even our own intuitions, that actually the best frequency measures did not come from books, but it come from subtitles of television series and films. Yeah? Now, to some extent this is quite surprising, but you have to think of this. So who are our participants doing these experiments? They are 18 years old, coming to university, and in the first month they have to take part in experiments like lexical decision tasks. What is the type of language they have been exposed to most? Is it the Bible? Is included in Coursera and Francis? Is it the Declaration of Rights? Also included in Coursera and Francis? Is it non-fiction, scientific books? Also included in Coursera and Francis? Or is it what you're watching on television? Is it what you're using on social media? Yeah? Twitter, Facebook, all these type of things. So we have the reason why these frequency measures are better is because they are capturing better what people have been exposed to. But again, we wouldn't have found this if we hadn't had this validation criteria. Yeah? If we hadn't had the English Lexicon project, it would have been impossible to search for a better frequency measure. when we started with these subtitles, we thought this will be nothing, because it is audit-free frequency, it is edited, the subtitles are not 100% what is said, etc., etc. So there were lots of reasons to think that this would not be a good frequency measure. Still, it turned out to explain most of the variance. But we also needed age of acquisition measures. Yeah? So they were available for 2,000 words, but if you have 40,000 words lexical decision data for 40,000 words, then you also need age of acquisition ratings for 40,000 words. Yeah? Well, you don't need them for 40,000 because some of these words were not known to the participants, so you take the 30,000 that is best known. Still remember, it was at a conference like this one when I met Victor Koeverman, and Victor had just discovered Amazon Mechanical Turk. And he said, you know, it's now easy to do research. You can just put it on Amazon Mechanical Turk and people can sign up, they get some money for it, and now you can run experiments with thousands of stimuli and hundreds of participants. And I had a bit of money, and he kind of tried to liaise with me whether I could spend some of my money with him. I said, yeah, that's good. And I said, what did you have in mind? Give me a number, he said. And I said, why don't we go for 30,000 words? And I still see Victor kind of, okay. I hadn't expected that one, but okay, let's go for it. Yeah? And actually, in 2 months' time, we collected all the data, and the cost was very reasonable. So, yeah. So, but this means that suddenly you have age of acquisition ratings for most of the known words. And while we were at it, we also added concreteness, and we added valence. Is it positive or negative? Does it arouse you, this word, or what it refers to? Is it dominating you, or are you dominating it? Etc., etc. A new one we are just about to publish, and you may not have heard about it, is prevalence. Yeah? Remember that I told you that some of the low frequency words are very easy words. And here you can see some. This is the frequency effect. Yeah? So low frequency words to the left take more time in lexical decision than high frequency words. We will immediately see what curve it gives. But what you see is that at the underneath, that there are some of these low frequency words that are responded to after almost 500 milliseconds, as rapidly as the high frequency words. Yeah? So it is not the case that all low frequency words are more difficult than all high frequency words. And we show these words. Yeah? Here you see a number of them. Mindfully, rollerblade, toolbar, bar, microbiologist, and so on and so on. These are words that are known to most people. Usually they are morphologically complex words, although they also include something like kilogram and recline. So, what are these words? Yeah? And then we thought, this frequency measure, it's always based on something. Yeah? For instance, the subtitle frequency measures is the type of language used in films. Yeah? Whoever talks about a rollerblade in a film? Yeah? Very few people are talking about rollerblades in films. They are out of date, although we have old films. Simplification, immobility, initialize. Is this used in films? Is this used in books? In certain books it is. So we need something else. Either we can try to improve our frequency measure, and we have tried to do that, and there are ways to further improve it. But we had a feeling after a few years of research that we would never get there with our frequency alone. And so this is when we started to think about how many people know the word. Yeah? What makes the real difference among these, between these low frequency words that are responded to rapidly and very slowly, is that people have the feeling that they easily know the words that they are responded to rapidly. Yeah? So why don't we ask it to them? So and we made a vocabulary test. So what you get a kind of a lexical decision task. You get 100 English stimuli, 70 are existing words, 30 are made up non-words, and you have to say which of these words you know. If you say yes to a non-word, you get subtracted. Yeah? And about 1,500,000 people have done this, yeah? Of whom some 100,000 people from Poland. Yeah? So we have a lot of data now on knowledge of English among Polish participants. And what we see, if you look at the frequency again and the percentage known, that here with very low frequency words there are quite a bit of words that are known to virtually everybody. Yeah? So these are the words that we are always missing. And we can add that to our list. And if you look, for instance, in Dutch, because we have also a Dutch lexicon project now, we have the data now, we see that after all the variables we had before, we explain an extra 6% of variance. If you look at the ELP, we explain an extra 3% of the variance. The reason why it is lower in English than in Dutch is because the ELP only includes the words that are on a frequency list. Yeah? So all the well-known words with a frequency of 0 that were not in the corpus are not included. If these had been included as well, we would even have explained more variance. Incidentally, this is not something we are doing for English and Dutch, but this is, oh yeah, oh yeah. I thought I had another slide. Okay, this is also something, it's coming later, something we are doing, have been done for Polish as well. And this is largely due to a student I had, Pavel Mandera, who has been very instrumental in making this all possible, because he is extremely good in programming, has good ideas. And it's one of the reasons why I have a very positive image of research in Poland. Yeah? So that's one of the reasons why I'm here. So, but one of the things you can also do now is you can look at the meaning of a word or get an idea of the meaning of a word by analyzing big corpora. Yeah? What basically we are doing is we are looking at a specific word and in the corpus look which words are together with this word, say in a window of 10 other words. Yeah? So for instance we could look at the word Poland and see which are the other words that are very close to this word. And then we get a vector. It's a little bit more complicated than that, but you can look it up on the website we have for English and fortunately not yet for Polish. And we can, for instance, add enter Poland. It's based on a 2 billion word corpus, so a lot of information has gone in. And if we then look at which are the words that you very often find together with Poland, you see Warsaw, Hungary, Polish, Krakow, and you see virtually all the names, including on the 10th position, Poznań. We can also look at Polish, and these are the words that often, very often, come together with Polish. And you can see it makes sense. Yeah? And this is now a way in which we can look at the meaning of the words, because they have vectors. And we can combine vectors with norms, so that if you have 1,000 norms, you can extrapolate them to more words, and this is now a very nice new development. Incidentally, we can continue, and if we are on the meaning of the words, we can also ask people what are the first words that come to your mind when you see, for instance, the word boy. What are the first word that comes to mind to most people is girl. And then you are asked to give 3 more. And thus far we have collected them again for English for 12,000 Q words. Yeah? You see, we are assembling more and more information so that you can use all types of information to select your stimuli, to make your experiments more interesting, also to analyze the influence of these variables. And as I said, it's not something we are only doing for English. We also do it for Polish. We have a few data sets But it's time, I've seen, to come to some recent advances. Remember, the big question was, how does the word frequency effect look like? I already gave you a glimpse, but this is how it kind of looks like. Yeah? There is something interesting here. It's a bit of a pity I don't have a stick here. This here is log 10 frequency per million. So 0 means a frequency of 1 per million. 1 means a frequency of 10 per million. 2 means a frequency of 100 per million, and so on. Yeah? Now, if you look very carefully, there is a very strong frequency effect, but it's virtually all below 10 per million. Yeah? Remember, this was the cutoff score for Morrison and Ellis. They were comparing this to that. Yeah? So they were kind of at the bottom of the mountain and comparing that to the valley. There is a big frequency effect, but it is below 10 per million. And it is true in English, it is true in Dutch, and it is true in French. Yeah? So this is how the frequency effect looks like. If you are comparing words with a frequency of 5 per million to 100 or even 200 or 300 per million, you will find a very shallow frequency effect. If you want to find a real frequency effect, you have to use words that are lower than 1 per million. Now there is something funny. Yeah? This is bad. Yeah? So you have here 0 and then it goes to minus. Yeah? People hate minus. Yeah? So it looks as if it doesn't really belong to the continuum. Yeah? It looks a little bit like a swimming pool. Here you have the shallow end where everybody can kind of dabble around, and here you have the deep dark end, yeah? Where you have to be versatile in R and in all these special programs to work with it. So what we needed was a better scale of frequency. Yeah? What was used most of the time was frequency per million words. Yeah? That's what everybody does. But it's not logarithmic, and we know that the frequency effect is logarithmic. It also suggests that the scale starts at a value of 1. And for Kucera and Francis this was true, because it was only based on a corpus of 1 million words. So 1 was the minimum that you could count. But now that we can count it on a corpus of 1 billion words, then there are many, many words that have a frequency lower than 1 per million. It also suggests that the difference between 1 and 2 is small. Yeah? Or between 500,000 and 1 million is virtually not of relevance. Yeah? Although we have seen that this is where the big mountain is. Yeah? Log 10 per million is a bad measure as well. It has negative values. And so we decided to propose an alternative measure, namely the zip scale. Now, what is the zip scale? It is, we already know log 10 frequency per million. Now, if you take log 10 frequency per billion, yeah, then you have to add +3 to each value you obtain. I've checked it for all the values, it is true. Yeah, as you know, with logarithms it will always be true. And then you get, instead of these values, you get the zip scale goes from 1 to 7. Everybody knows, understands it. 1 to 3 is low frequency words. 4 to 7 is high frequency words. And if you look at where the words lie, based on how well are they known, you see that now the scale really is in the middle of the words that are known to most participants. Yeah? So now we have at last a good frequency measure, so that everybody can use it, that everybody knows what a zip value of 2 means, what a zip value of 4 means, because what we are using now are very, very many different measures, except for this frequency per million, which is not a good measure. Remember that I wanted to know the frequency effect, yeah? And I showed you the frequency effect, but then we discovered that this frequency effect is not exactly the same for everybody. Yeah? Namely, when you learn new words, the frequency effect is kind of emerging. Yeah? Before you have learned words, you don't show a frequency effect. Yeah? Think of you learning a new language. In the beginning, you don't show a frequency effect. It's only after some exposure to the language that you start to show a frequency effect. Something else we see, if you do this in connectionist models, is that the frequency effect becomes smaller as you are overlearning the words. Yeah? As you've been exposed more and more and more to the words, your frequency effect becomes smaller. And what you must predict then is that your frequency effect will depend on the exposure you have had to the language. And exposure can be measured with a vocabulary test. Somebody who has read a lot, who has spoken a lot, who has heard a lot, knows many words, and will have a high value on a vocabulary test, and somebody who has done less will get a smaller value. So this is then how the word frequency curve interacts with knowledge of the word. Namely, somebody with a high vocabulary, so the blue line, the dotted line, they will know more words, so they will know all the high frequency words like everybody else, but they will know more of the low frequency words. If you look at the reaction times, the big frequency effect for them will be biggest among the low frequency words, because these are the ones they are now starting to learn. The very low frequency words, they haven't learned yet, so their frequency effect there will be somewhat smaller, but they will show a big frequency effect at the at the low end of the frequency curve, whereas somebody who is just learning the language, is also an L2 speaker, for instance, knows less of the language, has been less exposed to it, will show a very strong frequency effect at the high end. Yeah? So this is where we are now. And we can also show that this kind of predicts a stronger frequency effect in a second language than in a first language. Here you see some data in which we look at reaction times to English as a function of the first language. And you see that the English people, the solid line, show the smallest frequency effect, and that the second language learners show a bigger frequency effect. We also had vocabulary size data, and if we enter these, we don't see any effect of first language versus second language anymore. It all has to do with how big is your vocabulary size, how much have you been exposed to this language. Okay, I see it's time for some conclusions before you all fall asleep. Small-scale factorial designs are good to test specific theoretical predictions. If you have a theory, nothing better than an experiment to really test it. But to do so, first they must be powerful enough. So now we know that in the future we have done 2 small experiments, and we must know more about the environment we are working in. There is no big point in running experiments if you don't know what the value of your measure is, if you don't know how the effect of this measure looks like, if you don't know what values you have to compare with what values, if you don't know any of this, what's the point of doing a theoretically decisive experiment? And the mega studies and the big data are giving us a better view of which variables are important. It's important for you to know that these data are now everywhere. Yeah? You can easily use them. You just download the corpus, for instance, of subtitles, and you can do whatever analysis you want, because it's now becoming so much easier to do all these type analysis, even run them through parsers so that you know what part of speech they have and lemma frequencies. It's also possible to collect good semantic vectors. It's a pity that Pavel hasn't been longer for a year in our lab, or you would have had them for Polish as well, but I'm pretty sure they exist for Polish already. And by combining these semantic vectors with a few norms for a few thousand words, now you can get data for virtually every word. Yeah? So if you want to do all this work in Polish, you don't have to do all the work we did. You just collect it for 1,000 words, you use the semantic vectors, and you will get very good estimates for all the remaining words. And that's about it. Thank you.
Thank you for this lecture, and now we have 15 minutes for questions.
Yeah, this is working. So thanks for the lecture, that was really interesting. And I have a question about the corpora that I used for these frequency estimates. So you said that once corpora moved to using things like subtitles of movies and things like that, they became better predictors of the frequency of words in the real language.
Mm-hmm.
But subtitles are usually of spoken speech, and people don't usually read subtitles, right? But the tasks are all about written language. So you have sort of a cross-modal effect there from hearing words to reading words.
Yeah.
So do you think that makes a difference, or do you think it doesn't matter how you get the words in as long as you are exposed to them?
Yeah, to some extent this has been a big surprise to us. Because we started doing it in Dutch, there all films from non-Dutch speaking films are subtitled, so people read a lot of subtitles. And so we expected to find a strong effect there, and so that was what happened. But then we also saw it in French, we saw it in English, we saw it in German, we saw it in Polish, all countries where there are no subtitles, or not many subtitles to films. So this really tells us that the frequency effect is not modality dependent. That's the only conclusion we can draw from this. It is true though that if you combine registers, that you still get a better frequency measure. So it is good, for instance, to combine subtitles with something like Coursera and Francis books, but also with social media and some other, also books used in school. It's a very specific language. So it makes sense to combine all the sources you think an 18-year-old may have been confronted with, but has been encountered both visually and auditorily. Yeah, that's a conclusion we have to draw, which surprised us a lot. And we could never have done it if we hadn't had the English Lexicon project. It would never have been accepted. Even I wouldn't have accepted the measure.
Okay, any more questions?
It was all clear.
Thank you for a very inspiring lecture. I have two questions. One question is about the AOA and the reliability of the effect. Is there any research, because we know that this variable is quite challenging in measurement, is there any research that shows reliability within the same group, several test sessions with the same items that would show consistent results so that people really evaluate this in a consistent manner? And my second question is about the corpora. So, when collaborating with computational field, I see a lot of enthusiasm for Wikipedia because of the number of items. To a linguist, of course, it raised some doubts about what kind of corpus it is. So I was wondering what your opinion is about it.
First, the age of acquisition ratings. If you redo it, retest it, you get 0.9. That's about what you're getting. Also, if you look between groups, it's about 0.9. A more interesting question is, how valid is it? How well does it correlate with more objective measures of order of acquisition. And we have now some 10 studies all showing correlations of 0.7. It's even the case that it correlates very well with the CDI measures. I don't know whether you know the CDI, so this is about the first 600 words that a child acquires. If you look at the order in which these 600 words are acquired and you correlate it with the age of acquisition, so that is between the age of 2 and 3, 2 and 4 maybe, so that's even before people remember that they were learning these words, even there you get a correlation of 0.5. So these age of acquisition measures are reasonably good, certainly in terms of the order. I don't think they are as good as for a precise estimate of when a word has been acquired, because you see that people think most words have been acquired between 6 years and 12 years of age, and we know that this is not true. Yeah? Even you and me, we are learning 2 new words every week on average. So you see that people keep on learning words until they are 70, 80, depending on how good their mind still is. So age of acquisition measures are good to some extent, but they are also limited, and you're right about that. The other thing is the use of corpora. It's very interesting, because when we were making these semantic factors, we didn't want to use, or not only Wikipedia, we also wanted to use a big subtitle corpus and some other corpora which are really, how would I say, language people have encountered. And when we look at how good the semantic factors were to predict rhyming studies, they were better than only based on Wikipedia. Yeah? So if Wikipedia is your only corpus because it's so easily available and it has so much information, then you have the mind of Wikipedia, which may not be the mind of an 18-year-old at your university. Yeah? For instance, this is also something we saw, that some of the synonyms we got for the words were words we didn't even know. Yeah? But Wikipedia knew them. Yeah? So, to some extent, it is too good to be true for a human. Yeah? So if you want to know language, Wikipedia is good. If you want to know the human mind and what you can predict that humans will do, you have to give or use the input humans have been exposed to. Yeah, that's true. Yeah.
Thank you very much. I would like to return to the issue of subtitles as the sort of source of the corpus used to estimate frequency. Because subtitles, if they are taken into account, they actually they include translated language. And as a translation studies person, I know that translated language is already to a certain extent simplified, because translators do have a tendency to choose the more frequent vocabulary.
Yeah, I think part of the reason why subtitle frequencies are doing so well is because the high frequency words are really more high frequency in subtitles than in written language. Low frequency words are really less frequent in spoken language than in written language. And this is something very funny. You can speak and speak and speak and repeat the same words over and over again. Nobody will mind. But if you write the same word 3 times in a row, people kind of feel annoyed because you are repeating yourself too often. So you have to look for synonyms. You have to look for different phrasings. And so what you see is that language in written sources is much richer than it is in spoken sources. And we see that exactly in these frequency measures. And that, I think, is one of the reasons why they are doing better than spoken. It is true that for older people who have read a lot, that written frequencies can be better than spoken frequencies, but not for 18-year-olds.
Okay, we have time for one more question.
You just answered mine.
Oh.
So if not, then let's thank our speaker once again.